Welcome everybody. My name is Uyeshiro. I run the analytics team, analytics infrastructure team over at Pandora. I'm going to talk to you about big data and music today. So first of all, what is Pandora? Pandora is a personalized radio station, allows you to create personalized radio stations. Basically, you enter very easily to create a new station based on your favorite song or artist, and then you just sort of sit back and listen to hours of customized, personalized radio. So we play things that we think you'll know and love, and then we also try to throw you some new stuff as well. The company started back in 2000, and with the Music Genome Project, and in 2005 we launched Pandora the Radio Project on the web. But you can now listen to Pandora in literally hundreds of different connected devices, on your mobile phone, in the car, on your home stereo, and then of course still on your computer. So that's Pandora. Let's dig in and talk about the data. So just over 175 million registered users now, 67 million active monthly listeners in February. Those 67 million listeners generated 1.38 billion listening hours. Since Pandora's inception, those listeners have created 4 billion stations. And on those stations, given us 25 billion pieces of feedback, thumbs up or thumbs down, on how they think we're doing on their stations. So tons of data. We actually store every track that we play on Pandora, so that's quite a large data set now. So how do we manage it all? So I want to sort of first get into the infrastructure and talk about how we store and what tools we use. So Hadoop is kind of a blank slide here, but Hadoop is the core of our analytics infrastructure. So about 3 years ago, we migrated to Hadoop. Prior to that, we had a couple, we used Postgres as our relational database for our real-time data store. And about 3 years ago, we also used that at the time for analytics storage, and we scaled it up to a certain point, and we got to the point where we could put data in, but couldn't really do anything useful and get it out. So we started playing around with Hadoop and thought it'd be a really great fit for us. So we migrated both all of our business analytics and sort of all the offline processing sort of work that our recommendation team does to Hadoop. So the cluster is 200 nodes, 1.3 petabyte capacity now, which is fairly small by internet company standards. We're no Facebook or Yahoo or anything, but for us it's actually really big. I think we've got 120 application servers, 15 database servers that serve sort of the real-time Pandora. So this was a pretty big jump in systems for us. So let me start with sort of how we get data into the system. So we do sort of the traditional ETL from our transactional real-time databases. I mentioned we use Postgres. We use Redis for data storage, storing things that are slightly less important than what we store in Postgres. So we suck in data from those systems periodically. Right now we do it on a nightly basis, so we just have sort of very simple dumps from our database. And we keep the data in its transactional form in the initial step of importing it into Hadoop. And then third-party systems. So lots of data in other systems outside of our operational data centers. So ad serving is a really big part of the Pandora business. We're an ad-supported platform, so we pull in data from our third-party ad serving platform, financial systems, and a bunch of other things. So we've just built some connectors to pull that data in. So the stats collector, this is sort of this is a custom thing we built that's been really useful actually. So it's a data pipeline, a way for our developers to make it really easy to get data into the system. So we have data that we pull in from the databases, but a lot of time there's things you want to track that you don't really need to store in the real-time storage engine. And so those can just sort of come directly from the front end back into the analytics system. So we built a couple APIs. We've got Java is what we use in our application servers. So we put an API hook in our application servers. We built a little REST API. We've got a lot of clients that send, iOS, Android, and all these other devices that send analytics directly from the client. So those come into the stats collector, and we built this very simple web interface where you, as a developer, you go in, create an event, tell it what kind of fields you want to store, what the types of those fields are, hit submit, and on the back end it goes into Hadoop. Well, actually, so we use Hive on Hadoop, on top of Hadoop, which I'll get into in a minute. But it creates an actual table in Hive, and then the data starts flowing. It's not entirely real time, but it's about 15 minutes delayed from when an event happens on Pandora and when it shows up and can be queried in Hadoop. So just really lowered the barrier to entry to getting data into the system. A lot of things. So it's sort of, we've taken the tact of experiment first and standardize later. When you have this sort of open system with a bunch of developers, you're going to get some data overlap, and the data is not always going to be as clean as you like. But experiment first, see if this metric is even interesting. Maybe only use it for a couple of weeks and then throw it away. But it's not a lot of development work to get it into the system. And then standardize later as you find things that are going to become more permanent. So we use Hadoop for both business analytics through Hive and for offline processing. So one of the things we do when we do a lot of heavy lifting on Hadoop now. A lot of this stuff we used to do in Postgres databases. Our recommendation team especially does all sorts of experiments with the data, and then what they basically do is use Hadoop for the heavy lifting and then push that data back into our real-time storage. So that's typically either Postgres, Redis, sometimes Memcache if it's very transient sort of data. So a lot more horsepower with Hadoop, obviously. As an example, we track, we keep a record of every song that we play in the system, and over time that data set has gotten huge. So our recommendation team aggregates that up by artist and by track and uses that as spins and to see how popular music is and on various dimensions. So back before we went to Hadoop, we did this in a relational database, and I think we could go back about 7 days worth and get the spin counts for the last 7 days, which was fine, but you kind of lose that historical, songs that were really important back in the 90s versus how they are today. You don't really have that context if you're only going back a week. And so once we moved to Hadoop, this is not even the 200 node cluster, maybe 30, 50 nodes or something, but we were able to go back to the beginning of Pandora's history, 2005, crunch through all the spins, across multiple dimensions every night. And so the playlist team just had so much more data to work with. So getting data out of Hadoop, so that's sort of the half of it. The other half is getting data out of Hadoop and using it. So for analysis and data mining, different access patterns of accessing the data on Hadoop. Of course, we have native MapReduce. We have a bunch of system jobs that are written in native MapReduce, sort of optimized. They run all the time, very performant. But like 95% of the jobs and analysis that's done on Hadoop is through Hive. It's just very easy to write SQL queries. before we moved to Hadoop, we had a bunch of analysts and scientists in the company that were already very familiar with SQL, so it was a very easy transition. You know, a few minor syntactical things. We had to build some custom UDF functions to support some things that weren't already part of Hive, but it was really a fairly seamless transition for people that are not like crazy technical. So that was really great. And then sort of at the other end of the spectrum, we started using Tableau for more of a traditional business intelligence tool. And so that, I don't know if you guys are familiar with that, but that's a business intelligence, an actual product, and has a really nice UI for visualizing data. The sort of less technical or business folks that want to do some analysis, they can do sort of the drag and drop kind of, almost like in a really powerful Excel and visualize the data. The other nice thing about it is you can very easily publish and share dashboards. So you make something you want to share with the rest of the company. It's very easy to send that out, share it with a bunch of people. So what we've done is, it doesn't handle the sort of large data sets that we have on Hadoop, but we've taken the large data sets and aggregated them and put together a set of curated data sets that we push into Tableau. So sort of on the spectrum, the very technical folks can go as granular as they want and use MapReduce and get at the very transactional data if that's what they want. And then the other end we have sort of very curated, rolled up data sets in Tableau that a business user that's somewhat technical can have access to. So that's kind of the tool set that we use. Let's see. So let's actually talk about some of the ways we actually use this data at Pandora. So I'm going to talk a little bit about playlisting, and that's the way we recommend music. So we now have a dedicated group of engineers that really just work on coming up with all sorts of crazy new ideas on the best way to recommend music. So I'll just kind of go into it. So what we found over the years is that we decided, very early on, we were sort of hypothesizing about what would make for a good recommendation algorithm and just kind of throwing it out there and going with it. And that worked some of the times, but a lot of times it got us into trouble. So we've really taken a very scientific approach to it. Any change that we make to the playlist algorithms, we test very heavily and make sure that it's, that it's actually better and not just based on some anecdotal evidence before it actually goes out and rolls out into production. So we start with a hypothesis. The playlist team, other groups of the company, other people in the company come up with all sorts of interesting ideas. But we actually have to go and implement it and then do some serious testing. And as part of that testing, we've come up with a bunch of different metrics that we think we can use across different tests and give us a pretty strong confidence that this new algorithm is successful. So that's sort of the process. So the first part, A/B testing. All the playlist changes begin as a test. The nice thing about our scale now, 175 million users, 67 million active users, is that we can take a very small percentage of our user base and get some really meaningful feedback. So we'll siphon off 1% of our listeners, or sometimes it's even smaller, and throw them test songs as they're listening throughout the day. And it's not like they're getting a full session of this new test algorithm, but maybe we'll throw a song here, maybe we'll get one today, maybe we'll get one in 2 weeks. Most of the time, folks don't even know it, but if they like it and they give us some signals about it, or they don't like it, we can take that data and and figure out how that algorithm is really working. So that's one of the nice things about once you get some significant scale, you can perform these tests without really affecting users or without them even knowing, really. So if the challenger, you're doing this A/B test, the challenger beats the current champion, then it becomes the new champion. So an example, a few weeks ago, the playlist guys were throwing around an idea about the Beatles station in particular. They were thinking, well, the Beatles are this sort of iconic group and really ahead of their time, back in their era. So the hypothesis was, on a Beatles station, should we actually be forcing more Beatles music onto the station? Is that what people really want to hear? And so we tried it out, and someone implemented it, and we threw it out to a bunch of users, and it turns out that although there was a lot of consensus, anecdotal evidence, a bunch of people in the company thought this was a really good idea, it turned out when we actually got it in front of listeners that really wasn't the case, and the listening level of the actual Beatles songs playing on the Beatles station sort of adjusted to the normal level, and so they threw out the algorithm and we'll come up with something else. But that's sort of the basic pattern. So the metrics are very important. So you do this A/B testing, how you're judging the results of this test are very important, and you have to be very careful about what you're using as a judge. So improvements will come from not only better, crazy, more interesting algorithms, but also as you establish better judges to make sure that these are actually performing better. So I'm going to kind of go through the evolution of different metrics that we used over time at Pandora. And so way back in the day, sort of the initial, I guess I should say we always have sort of one top line metric that this is sort of the overall thing that we're judging these new playlist changes on. And then there's some secondary ones as well. But for top line metric, the first one that we started with years ago was thumb up percentage. So just how well a song performs in a certain context based on the feedback, thumb up and thumb down ratio. And that worked really great. And then along comes mobile, and people start really listening on iOS and Android. And they've got the device in their pocket or they're driving, and they can't pull it out to give feedback all the time. And so thumbs up percentage becomes a little less of a good indicator, for us. So we switched to total listening hours, and just a very, very simple. If we're playing the right music for you, you're going to come back and listen for more time. So that's the metric, and that works pretty well. But then we kind of realize, oh well, this overvalues the heavy listeners in the system. They have sort of a disproportionate impact to the playlists on these stations. And so I took a step back and tried to get something sort of similar to listener hours, but settled on listener return rate. So just how often a given listener comes back to listen again. And I'm sure we'll find a weakness in this one and come up with another one. But this is sort of how it works. We just sort of evolve these metrics as we learn and grow. So the bunch of deeper metrics that we get into. So relevance is one of the key metrics that we use for a really long time. And this goes back to the kind of the history of the company. And in 2000, our founders started the Music Genome Project, which was really the idea is to recommend music based on the musicology itself. How musically similar is this song with that song, instead of using just popularity as the sort of sole driver. So back in 2000, they started this project. The actual Pandora Radio didn't start till 2005, but for years we've been analyzing music. So every piece of music that plays on Pandora has been actually analyzed by a human. They came up with about 400 musical attributes that define the characteristics of, well, 400 attributes for a pop song. I think it's about 450 for jazz and classical, some of the more sophisticated genres. But so an actual trained musician, they either have a degree in composition or sort of equivalent life experience. We have about 25 music analysts on staff now, and all they do is listen to music all day. So we've been doing this since 2000 and really have established this really nice catalog of musical characteristics. Over 1 million tracks analyzed in the system, and we're still at it. I think we're like 10,000 tracks a month or something get analyzed. So the Music Genome Project really provides the basis for relevancy. What plays on this particular station should be musically relevant, and we're not going to throw you we're going to try to keep the music within that sort of musical genre. We don't like to really use genre as a term, but to keep it relevant. And the Music Genome Project is sort of our tool for doing that. So prediction accuracy. Prediction accuracy is another one. It's just how happy is the listener with this particular station. So this is one that's measured by thumbs. If you like the station, then we're doing a good job if you're giving us positive feedback. Musical diversity, this is one that we value really highly. So, the way your client makes a request to Pandora, and sort of behind the scenes we do all these calculations and try out different algorithms and try to figure out what the next set of songs is that we should play for you. And we get to this point where we have 2 songs that we think that you'll like about the same. We'll always pick the one that's sort of more musically diverse. So all things being equal, pick the one that's slightly more diverse, give you a little more experimentation, give you some new music, if we think you'll like them about the same. And novelty and surprise is really very similar. So all things being equal, choose the song that's more novel or we think will be more of a surprise in this particular scenario. And then, of course, awesomeness, which is a very key metric. A little hard to measure, but it's kind of that hell yeah moment. This is the right song at the right time in this playlist. And so yeah, my colleague who runs the playlist group talks about, he gave a similar talk one time, and this professor comes up to him afterwards and says, hey, you should really make use of the gyroscope in your app to measure this awesomeness, so you can tell, they really like the song, they're going to be jumping up and down, waving their hands around, and you can use that to figure out how awesome the song was. So we don't actually do that, but it was a great idea. So that's about it. Questions? Yeah.
So I have 2 questions. One is the first presentation today was about machine learning.
Mm-hmm.
Doesn't sound like the Genome Project has incorporated that. Typing music. The second question is, I listen to Pandora, and sometimes you guys are right on, and sometimes you're not, but I'm unique, but everyone's unique.
Yep.
What is the conclusion that would cause you to believe that you can choose music for people? It seems very personal.
Yep, exactly. So we actually do use a ton of machine learning algorithms. I mean, the Music Genome Project is just one of the tools we use to recommend you music. So we're actually hiring all sorts of interesting machine learning folks now. So if you know of anyone, please send them our way. But as far as the personalization goes, we realize, and that's something that we think internet radio is particularly good at, is delivering a very personalized experience. So when I'm talking about these algorithms, as you're personally listening, you're not going to necessarily be getting the same algorithms. Like certain algorithms may work better on certain types of listeners. So you're going to be getting different algorithms, different combinations of these algorithms, and also we take into the factors all the signals you give us, the thumbs up, thumbs down, any other sort of signals we can get from your listening experience. So all of that, and your history, all of that sort of factors in, and we build something personalized for you. So it's not just sort of boilerplate, this is the algorithm of the day. It's very personalized and very complex.
Okay, related to data collections, I'm here. What type of data do you collect in terms of, the textual data, like for example, text, numbers, but also there's a music file, wave file, the file of the music itself. Mm-hmm. Are you using the music file itself as part of the data that you analyze, or only just the people are classifying it? Do you use a classifier, like automatic classifier with machine learning to analyze this particular voice data?
So we don't have an automated process to analyze the WAV files, the music itself. But I mean, that's what we use our music analysts for. They actually sit and listen through the whole song and score the song on a bunch of different attributes. So they're the ones that are providing this musical context for us. Cool. I think.
I'm sorry, so I'm just talking about the algorithm. So the one person mentioned machine learning, and I think, looking at your problem and personalization, it's a very complex environment. So I'm wondering, did you try, for example, the genetic programming approach for this kind of algorithm? Because it could be very beneficial, or any other artificial intelligence algorithms, because you have very, like a bunch of variables which can characterize the songs, the person, and so on. So it could really help in the high dimension space to solve this problem in terms of optimize some ultimate metric, whatever you have in your system.
Yep. So I'm not actually too familiar with those specific algorithms that we've been trying recently. We've got a bunch of really talented machine learning folks on the team that are doing this now. But I think they have experimented with taking algorithms from other fields that are useful in other fields and trying to apply them to music. So that's something we're continually experimenting with.